Okay, this is going to be called Big Global Perimeter Problems Proof Flat Earth. I made two videos on this, a few videos on this topic in the past year and a half or whatever, but I've made two in the past week or so. The last one I made I will have taken down because there was a few issues. I calculated some stuff wrong. So this time I've made it more simplistic and I've made the triangle bigger. Okay, so here is Africa, right? So what we're going to do is we're going to deal with three cities: Cape Town, Rabat, and Tehran. Okay, so what I've done is I've drawn a triangle between the three: Cape Town, Rabat, and Tehran, and I've gotten their distances between each one, right? Before I go to that, I just want to show this is a representation we've all seen before. I'm sure most people have. The difference between the Mercator projection and the Gauss-Peters, right? So here is one, here's another one. The Gauss-Peters is in blue there, and here it's in green. So you can see there's a massive difference in how Africa looks and the world in general looks, right? And here's another one. Excuse me, and there's a scale down here of 1,000, kilometers and 1,000 miles. Obviously, the scale is a straight line because distances between locations, airline distances, and just basic distances, right? Basic between 2 points, between A and B is a straight line at all times. Miles are lines, straight lines. Kilometers are straight lines. And of course, nautical miles are straight lines. They're a type of mile. They're made up of feet, you know. You know what I mean? This shouldn't be a problem, but anyway, it is with some people. Either way, the reason for a point of me showing this is that I've also, just for visual or just to show, drawn the same triangle on this. And as you can see, it looks slightly different from the other one, because on the other one, Africa is a lot more squished. But this is Gauss-Peters projection type map, and this is a more supposedly a more correct depiction of the land sizes of the land masses in relation to each other. So as you can see there, how massive Africa is. Like, I mean, regardless of how big the United States or Australia is, they pale in comparison to the size of Africa. It's absolutely huge. And Russia, of course, up here is massive too. But you can see here there's a bit of a difference in how it looks, how the triangle looks. And at the scale down here, you have 1,000 kilometers or 1,000 miles. So for that. So as you can see, what we have here is a triangle. 2 dimensions, that's it, right? That's what it is. So I'm going to go back to the other one briefly because it's more visually better. So, right. So each line is a straight line distance between the points. Like Rabat to Tehran, Tehran to Cape Town, Cape Town to Rabat. So it's straight line distances between the 3 points, right? It's not arc length distances like they want to claim. It's a straight line distance. Because if it wasn't a straight line distance, we wouldn't be able to use maps and straight line distances between them, as I'm going to show here in a few minutes. Like as I've shown in the past. But because I made a few calculations in the last, incorrect calculations in my last video that was pointed out to me, and when you're wrong, you have to just you accept it. So I calculated things wrong, and this one I did things more correct. So, but it doesn't matter because the premise of this is, and the premise of my last video, the one I've taken down, that is the correct premise. You can't go against that. This triangle placed onto a spherical surface will increase in perimeter length, and it will increase in internal area because it can't not. Now, we have maps that we use all the time. We've used them forever. And on no map anywhere, regardless of if it's a very detailed map or very simple map, you will never find down where you have the just show where the scale is, whatever. You will never find a formula that will allow you to turn this map and the distances between locations into from a two-dimensional projection into a three-dimensional sphere. You won't find that. So when I am showing the triangle here like this, or on this other one, just to show you, this triangle here, right? That triangle here is a triangle. It can only exist on a two-dimensional plane. On a flat Earth, it can only exist. I'm not saying flat Earth is two-dimensional, but its underlying baseline is two-dimensional. And if we're going to draw a triangle between 3 points, it's going to be a triangle. Not going to be any curved lines. Not going to be any bowed out from the center positions. There won't be any extra area added inside. The area will be the area. So there's no way around this. That what we're looking at there that can be placed onto a map can only be placed on the map, and the map be representative of reality if the Earth is flat. Because you cannot place that onto a map, this triangle between these 3 points, and still say it's going to be projected back onto a globe when it never came from a globe to begin with. For that to be projected back onto a globe, then you would have to have the correct formula for changing these distances in area. Because if you wanted to go from, let's say within this triangle, if I just go in this slightly, if you wanted to go from, let's say, Porto Novo to Addis Ababa, then that whole straight line there that I could draw between those 2 points, that would be increased in distance. So whatever that would be here, if I calculated that out in relation to this triangle, wherever that would be there, if the Earth was a globe and this was representative of a globe, and this could be placed back onto a globe, then that distance would increase because there'd be an increase in area between those 2 points. There'd be no way to stop that. That's just reality. So this is the problem. You can't state that this map can be, or let's say this, just Africa here, can be placed, and the Middle East can be placed back onto a spherical surface and everything be hunky-dory. You can't do that because at that point you're either claiming that all these distances are wrong, or this map is completely wrong and you don't have a map, because it means that you're hiding a load of distances and area that you're not shown on the map. And there's no formula down where the scale is or anything to convert it, to back to globe kind of thing, right? And I've seen people complaining in my last video, the one I took down, because I was showing them a pretty detailed, I think it was the last video of the one before that. There's a pretty detailed, I think it was the one before that, there's a pretty detailed map of Lake Erie. And there's 3 different scales on the map, and the people were asking why come there's different scales on the different parts of the map, because they weren't understanding that the grids being used have been manipulated, so they need to change the scales. But the point being is that they would need a lot more than differing scales if the Earth was a globe, because there'd be no way for these 3 distances to be able to be drawn as a triangle between these 3 points, and they'd be correct. It just wouldn't be possible, because you can't go from 3D to 2D and 2D back to 3D. It's just not possible. If you're talking about distances and area, you can't do that. Think about all the plane flights that happen in the world. Think about, over land masses. Think about it. There'd be no way for them to be flying from point A to point B and using a distance that can't be given on a map. If that distance can be shown on a flight chart and can be shown on a map, which you can, then they're flying straight. Now, not that we know they're flying straight lines, but the point is that those charts and maps can only exist because the Earth is flat. That's it. That's the only way for them to exist. Right? If the Earth was flat, maps as we know them could not exist. We would have to have extras with the map for the map to be used. If the Earth was a globe, there'd be no way for us to not have a formula for each map to convert the distances between points, that this is actually that distance and there's this amount of area between your triangle, blah, blah, blah. You would have to have that if the Earth was a globe. But that doesn't exist on any map anywhere ever. Okay, so just to support this, let me go to here. Right, here is, how far is it from Tehran to Rabat? It's 3,247.7 miles. So how far is it from Rabat to Cape Town? It's 4,959.2 miles. And how far is it from Tehran to Cape Town? it's 5,216.13 miles. So I put all those into the triangle calculator. Here we are, right? So 5216.3, 4959.2, and 3247.4. And that gives us a perimeter of 13,422.9 miles, right? The area is 7,804,420.70519 square miles. So that's the area, okay? So if we now go to what I did is I did this again, right? I got let's go to here, is I took those three lengths, right, and into Google, and if a triangle has sides of 4959.2, 5216.3, and 3247.4, and is placed onto a sphere of radius 3959 miles, right, the perimeter of the spherical triangle will be 4,399.9. So the perimeter is 13,422.9. As a normal triangle, its perimeter is increased to 14,399.9. That's what, as a spherical triangle, that's what it, right? A claimed spherical triangle. But that's what it will be. It will be an increase, right, in the perimeter size. Okay? So then I went, okay, so that what I subtracted one from the other, and when you subtract one from the other, there's 977 miles. So what that means is to place this back onto a globe, right? It's just going to go minus, right? Sorry. So to place this, let's say, map of Africa and the Middle East back onto a globe, you would have to add 977 miles to its perimeter. Now, how are you going to do that and deal with the extra area? Now I'm going to show you the area problem. So that's 977 miles is what is the difference in perimeter between this as is with actual distances and that if placed onto a globe. It's increased, the perimeter has increased by almost 1,000 miles, right? So now I'm going to go to here a sec. And what I did was I divided 977, I took the 977 first, and I added it to each side, and I made a triangle out of each side, right? So this is in 2 dimensions. I'm going to go to the spherical triangle part in a minute, but this is in 2 dimensions, right? So as you can see, the area here is 7,804,420.7 square miles, right? So when I added the 977 to one side, right, I got obviously a bigger, the perimeter is 14,399.9, as it would be for a spherical triangle. Now this is 2 dimensions, but I'm just using the same perimeter length, okay? And I added it to one side, one of the sides. I got an area of 8,466,300.6, blah, blah, blah. So an increase of a million or whatever, right? So then I did it with the next side. I took it off of that side and added to the next side. And I got, same obviously, it's the perimeter is the same, 14,399.9. But the area is increased, it's 9,758,376, right, 0.99. Right? And then I did it with the third side. And the perimeter is the same again, 14,399.9, and the area is back to 8,011,971, blah, blah, blah. So obviously, because I suspected this, because it depends on the triangle itself, how much area it covers in square miles. So it changes, the area changes if I add just the 977 to either one of the sides. So I said, right, just for transparency, I'd show that. And instead, I divided the 977 by 3, and I added each of those 1/3 to each side, right? And I have the same perimeter, obviously, of 14,399.9, and I have an area, and this is the best way to do it because it's been the most fair, adding a bit to each side, of 9,105,744. Okay, 0.32317 square miles. So if I go to, if we go back to here a sec, and I just show the difference, and this is in 2 dimensions, remember, it's not 3, 2 dimensions. So 7, not here, go to here first, sorry. my fault. Sorry. So 9, 105, 105, 744, 744, 323, 323, 17, right? So minus, if we go to minus, back to here, 7804, 7804, 420, 420, 705, 705, 19, and that equals, right? So that equals 1,301,323.61798. So 1,300,000 over 1,300,000 extra square miles, right? Just in 2 dimensions, just taking the extra perimeter length that would be added on for, if I just taking this and placing it onto a globe of radius 3959 miles, and then taking the perimeter length of that extra perimeter length, which is an extra 977 miles, and then placing that into turning that into a 2D triangle, right? That's 2 dimensions. It's even that in 2 dimensions, right? Sorry, in 2 dimensions, it's over 1,300,000 extra square miles in between in area. So even a 2-dimensional triangle with a perimeter of 14,399.9, which is right, this one 14,399.9. Even a 2-dimensional triangle will have an increase in 1,300,000 square miles. So that's just 2 dimensions. So if we now go to area of spherical triangle of perimeter 14,399.9 on a sphere of radius 3959, right? Assuming an equilateral spherical triangle on a sphere of radius r 3959 with a perimeter of 14,399.9, its area is approximately 12,268.478, right? Units squared miles, right? So if we go back to the calculator, first of all, we must first go to here, and then where's the calculator gone? To here, right? So this is, oh sorry, I should go to, oh my damn, made the same mistake a minute ago. Should go to here, right? 12,268, 487, 487, right? And minus, we'll go to here and find the calculator again. Minus 7,804, 420.70519, 70519. Okay, equals. So that means that's 4,464,066.29481, right? Right, added square miles of area, right? So that means that to bring this back to reality, to place this triangle here between these 3 points on this map of Africa and the Middle East, for these 3 distances to be placed as a triangle, to be placed onto a sphere of radius 3959 miles, the circumference or the perimeter must increase by 977 miles, and the internal area must increase by almost 4.5 million square miles. So that's some massive difference. This is what I'm talking about. Like on the small scale, people can say, this doesn't matter here and that doesn't matter, and it does matter, because even a small amount of perimeter increase will have a profound effect on the area. This is something I do understand, right? You cannot increase any of these lines by a little bit, and the area, even a little bit of increase in the perimeter, changes the area massively, right? There's a much bigger change to the area than there is, like, so a small change to the perimeter will give a big change to the area, kind of thing, right? So this means that for this, let's see if I can find it here. This means that for this map to be usable, right, and the Earth be a globe, then there has to be formulas added in to this map and any other map that allows for that extra 977 miles, right, to be added to this triangle, right, at these three distances between these 3 points, and for the almost 4.5 million extra square miles of area. That's what I've been talking about. This is the point I've been making between reality, where we use a map, a two-dimensional map, and a two-dimensional map, and I know there's topographic maps that obviously that show a third dimension to elevations and stuff like that. But the overall, you're not going to take those elevations into account when you're talking about a distance between A and B, right? And B and C back to A. You're not going to do that, right? There is no way around this for the borders. There is just no way around this. Every map in history doesn't have the needed formulas to convert from the map to the globe. It doesn't exist, right? There is no 977 added to this perimeter that you can calculate for off the map. There is no almost 4.5 million extra square miles of area in between the perimeter walls that you can calculate for off of formulas on the map. Those formulas don't exist. They're not on any map, because maps are, regardless of what they want, whatever way they want to mess around with the latitude and longitude grid, incorrectly turn it into an XY grid. Instead of placing an XY grid onto it, they're trying to turn it into an XY grid to mess with the time zones in places like Australia, right? Regardless of what they want to do, regardless of how they want to maneuver the land masses around and the continents around, in the end of the day, the fact that the map is two-dimensional, and we can use that two-dimensional map and get correct distances and directions and stuff along a landmass, right? And you can create a triangle right here, and you can fly that triangle, right? There is no way around it. Like, you cannot have a flight go from one point to another, like a big long distance like that, right, all along the land, across this piece of water here, and into up to from, let's say, Cape Town to Tehran or something. You cannot have that and not have to add in that extra distance, right? If it's on a globe, that won't be a straight line. That'll be an arc length, and there'll be an extra distance. And if you wanted to fly then from Tehran to Rabat, and then Rabat back to Cape Town, you're using charts, you're using maps, you're not using globe. Those charts and maps might be trying to make people believe it's a globe by messing around with the coordinate systems on them and a lot of other malarkey. But the very thing that they need on that map to be able to convert this to a spherical claim triangle of an extra 977 miles in perimeter and an extra almost 4.5 million square miles of area does not exist. And that's it. So yes, me and others might get the odd calculation wrong, but the premise is correct. The premise is correct, and the premise is what needs to be dealt with. And if you're not dealing with that, it's because you can't. This is to the borders. So that's what I've got to show. I don't see how this can be dealt with, because all they can do is present a map. Yeah, that's the 2D map that debunks your globe. That's the point. So that's all they can do. They can say this scale here and that scale there, because they don't understand what's happening with the coordinate systems. They don't understand. They can try and say, oh, it's only 0.42%. That means absolutely nothing. You don't have the formulas for the extra perimeter length and the extra area. They don't exist because they're not needed, because there is no extra perimeter length or extra area. In reality, that only exists mathematically in a mathematical conceptual world called globe Earth. That's the end of that. Thanks for watching.